Welcome once again to Aditya lectures on electronics and optics. Today I will demonstrate the parameter sweep by changing the dimension of this particular structure. Now, before discussing the parameter sweep, let's understand what is the structure. This is an anti-reflection coating. Here the N1 is one of the refractive indices and N2 is sandwiched between N1 and N3. The condition is that if the N2 is equals to root over of N1 and N3 and the dimension, there is the width of this layer N2 is equals to lambda naught divided by 4 N2. N2 is the refractive index of this middle layer and lambda naught is the free space wavelength. The wave that incidents normally at this interface will be transmitted, entire wave will be transmitted to the third layer and nothing will be reflected back. So such type of anti-reflection coating you can use where you need to absorb most of the optical energy, for example solar cell. But one of the most disadvantage is the absorption takes place only at the normal incidence, and this is very disadvantageous for a fixed mounted solar panel because the light coming from the sun will incident perpendicular for a very limited period of time on the solar panels. So therefore you may not get full absorption for the most of the duration of the daytime. Our purpose is not to improve efficiency of this particular structure. In this case, I will show you that at the normal incidence, the entire wave, the entire power will be transmitted to the third layer, and as the angle will vary, the reflection also will increase. But the same thing I want to observe by varying the width of this structure, width of this middle layer, that means the D. So in this case, I want to study what happens if I change this dimension. The standard theory states that the dimension, in order to get a full absorption, must be expressed by this particular factor. Now here I want to study what will happen if I change this dimension gradually from less than the theoretical value to greater than the theoretical value. In order to do such kind of experiment, I need to make two type of parameter study. First one is that the parent sweep will be the variation of the dimension and the child sweep will be the variation of the angle starting from less than 0 degree to greater than 0 degree. But one more thing we have to keep it in our mind, that while I am decreasing the dimension of the middle layer, all two layers will automatically be adjusted accordingly. While I am increasing the dimension or the width of the middle layer, all the two layers will automatically be adjusted. So these things we have to keep it in our mind. So let's start. The similar type of structure I made it for you, where you can see this medium 1, this is the medium 2, and this is the medium 3. Medium 1 has a refractive index of 1.4, medium 3 has a refractive index of 3.4, and the refractive index of medium 2 is calculated as per the theory. The wavelength that I've chosen for this simulation is 0.5, so therefore the width of the middle layer must be the wavelength divided by 4 times N2, and that gives me 0.057 approximately in micrometer. And here I put two monitors, one for the transmission and one for the reflection, although I'm interested to record only the reflection because I told that for the normal incidence in such type of configurations the reflection will be 0, and the reflection is recorded under this analysis group. And if I right click on that, RCM is the variable that I have defined, and this RCM is recording the transmission from the reflection monitor, that is this one. So everything already you know from my last video, and if you are new to my channel and you are interested to the construction of the basic structure in Lumerical, please refer to my previous videos on that. So now here I have simulated this angle variation. I have started this variation from -30 to +30, and I have recorded the reflection. And if I right click on that and visualize this R, you can see that the reflection is coming 0. The y-axis is the reflection and the x-axis is the angle. So the reflection is coming 0 at the 0 angle, that means at the normal incidence. But the major concern for this simulation is to study this structure, such kind of structure, by varying the width of the middle layer starting from some value less than the optimum one to some value greater than the optimum one, and the optimum value of the width is this one. So to do that, what I'm going to do, I'm adding another sweep. This is the parent sweep, as already I did it for my previous simulations, and I'm defining this as the width sweep, and right clicking on that, going to the edit object. So here I'm adding a new variable, and here I'm changing the value. I want to simulate for 4 values, so I'm giving the values 4. Now here I'm referring this one as D. Set parameter model, going to the object under the model group and going to the medium 2, and in this medium 2 I'm going to set the X max, and initially the end of the first medium was at 0.5 micrometer, and counting this width 0.057 micrometer approximately, the end of the middle layer is appearing at 0.557 micrometer, because the 0.5 micrometer should be added. Here I'm changing this, suppose from 0.51, 0.52, or rather 0.52, 0.54, 0.56 and 0.57. So the optimum value 0.557 is appearing in between 0.56 and 57, but although the simulation will be at 0.56 and 0.57 exactly. And one more thing, the value, the X max, should be of type length, so I must select the length in micrometer, and obviously these values must be changed accordingly. So 0.52 micrometer, 0.54 micrometer, 0.56 micrometer, and 0.57 micrometer. And now I'm assigning the monitoring variable, which is the R, and which is being referred to its child sweep, which is the angle variation. Now before going to the simulation, what I will do, I'm just selecting this middle one. You can see the selection is done by observing these red dots. Now I'm right clicking on that, and first of all I'm animating this one. Look, this is the animation. One major problem for this animation is that I'm animating only the sandwich layer, that is the medium 2. But during my animation, what I expect that everything, the medium 1, medium 2 and medium 3, everything will be animated accordingly or automatically, and which is not happening in this particular case. So in these particular cases, we should take help of the power of the scripting for the Lumerical. In order to take help of this power of the scripting language of this Lumerical, I'm going to delete all these mediums. Now we have to get that, I'm going over there and I'm assigning the structure group. Going to edit, the coordinate of the structure group should be 0, 0, 0. Within the structure group, under this properties tab, as you can see, I can add new values or new variables which I can use in my script. So first of all, for example, I'm assigning that m1 x span. So m1 x span should have the unit of length, and the unit is in micrometer, and the span is 1 micrometer. That already I did in the last case. Now I'm going to add a rectangle. So the command is for add rect. If you test, you can see that there is no error. So my command is successfully run, and if I apply, you can see that one rectangle is appearing over there. But I have to specify much more things. First of all, name. Set name is the command. To set name is within the quotation mark medium 1. I have to set the X span. So set X span. Now you can directly put 1 micrometer, or you can use the variable that already I have defined under this property window. So I'm just copying this one and pasting over there. Now be careful, don't put a quotation mark over there, as this m1 x span is a variable, not a specific constant, text constant like this medium 1 and all these things. Setting the y coordinate, setting the y span is 1 micrometer. You have to mention this micrometer by this 10 to the minus 6, otherwise it will not work. Then I'm setting the z span as the same and applying that. As you can see, dimensionally my structure is looking like the previous cases when there was no scripting. Now I need to set the material. One more thing, here I only have defined one rectangle, but the number of rectangles are appearing over there. The reason is that this construction group, before doing anything, you must click this construction group. That will bring a command delete all, because under a particular group, before executing all its command, the delete all command will be executed, and it will first delete all of the existing structure under the structure group, and then it will rewrite only those structures for which I am doing this particular coding. So here if I put it, you can see only medium 1 will appear. Now you can make it 1.4 or 2.4 over there, but it will not work, because right now all axis of the medium 1 is available through the structure group. So therefore, I have to set the refractive index for the medium one through the structure group only. I can set it in two ways. So I can set, if I'll go over there. So first of all, if you want to set any arbitrary refractive index, so you first have to set the material by the object defined dielectric, then you have to set the index and the index that you can supply. So you have to use two set commands to set any arbitrary refractive index for a particular medium. Otherwise, you can choose the material directly from this material library, but unfortunately you have to put exact material that you can see under the material library, and you cannot copy these things. You cannot have any other mechanism so that you can directly bring this exact text to your scripting or coding. Anyway, so I have found a different way to do this. So first of all, I'm setting the material. So I don't know what is the exact text that I have to put it over there, and I cannot copy it from the medium property. So I'm just clicking the test. So there you will find the error, and the error will show you the possible replacement for the materials, and from here you can copy that particular material. Now here I have already set the refractive index of N1 as 1.4 as custom 1. So custom medium 1 is my refractive index under the quotation mark that is holding this 1.4. Now there is no error, and if I put it, as you can see, the color gets changed, and already I made this particular color through this material property. Or you can do it in different way that I will show you later. Now the middle layer, and for the middle layer we have to calculate this D. So N1 is 1.4. The same calculation I did it over there, I will do it over here also. N3 is 3.4 and N2 is square root of N1 and N3. And as you can see, there is an error, and that error is due to this semicolon. The D will be the wavelength. Wavelength also you can define over there. That should have also the unit of length in micrometer, 0.5. Wavelength divided by 4 divided by N2. Okay, so that will be the width of the middle layer. What is my concern in this simulation is to study this structure by varying the width of the middle layer. So to do that, I need to access this dimension D from the sweeping variable or sweeping commands. So therefore, you should define this D over there, because this variable you can access through these sweeping commands. So here I'm defining this D, and it should have the length in micrometer, and the value is 0.0572937 in micrometer. Now I'm copying this add rect, pasting over there. So medium 1, the name I'm changing to medium 2. Now in this particular case, I'm not defining in terms of xpan. I'm defining xmin. What will be the xmin? As I already told, the minimum of the second layer should be the end of the first layer. So that will be the span of the first layer divided by 2. So span of the first layer was 1 micrometer, and divided by 2 will be 0.5 micrometer will be the minimum or the starting point of the middle layer. And the end value xmax should be the last value, minimum value, plus this D value, the D that already I have defined over there. So this will be xmax, and all other thing will remain same except this material. Now in this material, custom medium 2 should be my second medium. So this one, this is a custom medium 2. This is my second medium. So everything set. If I click apply, you can see the same layer appeared as a medium 2. And for medium 3, I'm adding the third layer over there. I'm changing this name as medium 3. Now the minimum value of the medium 3 will be the maximum value of the medium 2. So I'm just copying this one and replacing this one. And the end value or the xmax for the medium 2 should be the minimum value plus 1 micrometer. Okay, you can set it anything else, any other values also. And I'm changing this value. Now for this medium 3, I have not defined any custom medium because I need to show you another example. This material I will choose from this object defined dielectrics, means arbitrary value I can assign. Although in this particular case I will not assign the arbitrary values. Now for this command means I have opened the material value to give the value directly by the user. So I'm setting now this index should be 3.4, or rather you can define this N3, N1, N2, N3, whatever, 3.4. And remember, this N3 is a refractive index, so the unit should be in terms of the number, assigning as N3. So applied, and you can see that everything is appearing, or everything is looking like as my previous structure. Now I need to modify this width sweep. Going to edit. Now I'm interested to change the dimension through the structure group, not through this model. So I'm going to model, to object, going to structure group, and going to properties, and over there this D. So here I need to change these values also. So this is 0.02. The variation should be 0.02, 0.04, 0.06, 0.08. Now I'm adding this thing and animate. As you can see that everything is being animated automatically. The width of the third layer is adjusting according to the width of the middle layer. But another thing is that the width of the FDTD along the X direction must also be adjusted automatically. Although you have seen during the change of the middle layer, it is not crossing the boundary of the FDTD, but still if you have some situation when you need to change the boundary of the FDTD accordingly, so in order to achieve the automatic change of the FDTD boundary according to your structure, you also have to script for the FDTD also, but that thing you have to do under the model group. So I'm going to edit, so over there going to script, and remember, do not click on this construction group because that will bring another command, that is delete all, and that will delete everything that already you have under the model group. I'm not bringing this construction group over there, but specifically if you do not delete this FDTD before initiating this script under the model group, multiple FDTD will be generated, and for a particular simulation only one FDTD is allowed, so automatically you will be prompted for an error that you have multiple FDTDs. So to do that, first of all I will select the FDTD and I will delete that. Now I will add the FDTD, new FDTD. I'm adding the new FDTD and I'm setting the dimension as 2D, setting the Y minimum boundary condition, that is block, Y max boundary condition, that is also block, and for the X boundary, the X min BC, that should be PML, and Y X max boundary condition, that also will be PML. Okay, now coming to the width, so set Y span as my structure is, so my structure is spanning up to 1 micrometer, so I'm just bring my FDTD boundary within the structure, so that will be 0.8 micrometer. This is the Y span. Setting the Z span also same, but for the X max and X min I need to do a different thing. So X min, the X min should be around the middle layer, around the end of the middle layer, and the middle layer ends at 0.5 micro, minus 0.5 micrometer. So here I am putting at 0.4 micrometer. The X max will be automatically adjusted as the width will be changed. So here I need to do a different thing. So to do that, first of all I have to call the D variable that I set under the structure group, and the D variable here also I am assigning this D value, although right now this value has a scope only under the model group, and this D has no relation with the variable I have defined under the structure group. So I'm going to assign into the new variable, that is also the D, under the model group. To do that I'm using a command get named within quotation model double colon. Model means I'm referring this model, thereafter double colon structure group means I'm referring this group. So whenever you have to refer any group under the model group, you have to start using double colon model and double colon followed by the name of this particular group, and here I'm writing this variable D. I have to put a quotation mark over there, add FDTD. This warning is not so important in this case because this FDTD is available over there. And now the X max, since the D is available to us, so what I will define, the X max should be 0.5 micrometer, which is the end value of the first layer, plus this D means I've just covered this one, plus the maximum value of the maximum X max for the third layer was 1 micrometer, and for that I will define 0.8 E minus 6, so 0.8 micrometer. And if I apply, the FDTD gets shifted over on the source, and that is not desired. It means is I am having a problem with the X minimum value, so there should be a negative value. Now it's correctly came. If I animate once again, according to the width of the middle layer, everything is changing and everything is adjusted automatically. So now I'm going to run this parameter sweep, and before going to run this one, I just want to remind you that this optimum value of the width is appearing in between 0.06 and 0.08. So here I should come the optimum value, but I think this one is basically very close to the optimum value, but I think I should change it to 0.057 because this value is much more close to the optimum value. Let it be the optimum value. So I'm running this one. Look, the angle is varying, everything is changing accordingly, so I do not need to bother about anything at all. Now the simulation is done, and to check the results, go to the visualize and R. Initially there is a two-dimensional plot. To check the 1D plot, you should click on the line, and I should change this x value, x-axis from D to the angle. Here the plot is appearing the reflection with respect to the angle for a different values of D that I have simulated. So first of all, you can change the unit of this D value, this micrometer. So it is 0.02 micrometer. So for D is equal to 0.02 micrometer, this is the plot, and as you can see, at normal incidence the reflection is not zero, and this is at 0.04, and which is appearing close to 0.057, and you can see at the normal incidence the reflection is gradually coming to zero, and if you simulate more points or more for more values of D, you can observe that the reflection is gradually coming down to zero, and this is the optimum value, and at this particular point you can see the reflection is appearing zero. That already I have shown you for the first case when there was no scripting, and this one is for 0.08 micrometer, which is greater than the optimum value, and in this case also the reflection is not coming down to zero, rather it is increasing. Less than the optimum value, the reflection is increasing, and greater than the optimum value, the reflection is increasing. So that's all for today. In my next tutorial, I will try to demonstrate the basic theory of surface plasmon resonance, and thereafter I will show you the simulations with the surface plasmon resonance. Till then, stick with my channel. Thank you very much.